Good day everyone, Marielle Sucgang here, along with my groupmates Nicole, Cantero, Camela, Delfin, Giselle Paglinawan, Jorge Paglinawan, Cheryl, Roque, and Leif Talens. We will be presenting the Chapter 9 on the topic Database Management Systems. This chapter discusses the database approach to managing an organization's data resources, highlighting its distinct philosophy, strategies, techniques, hardware, and software compared to flat file environments. It begins by contrasting the database model with the flat file model to illustrate its advantages. Later sections delve into the roles and relationships of key elements in the database environment, such as users, the database management systems, the database administrators, and the physical database. The chapter also explains the characteristics of the relational model and covers various database design topics, including data modeling, relational table creation from entity relationship diagrams, user views, and data normalization. Finally, it concludes with a discussion of distributed database configurations in centralized, partitioned, and replicated setups. Next slide, please. Here are the learning objectives for this chapter. Next slide, please. Let's move on to the overview of the flat file approach versus database approach. Next slide, please. So let's first discuss the flat file approach of data management. Next slide, please. Flat file database is a type of database that stores data in a single table. This is unlike a relational database which makes of multiple tables and relations. Flat file databases are generally in plain text form, where each line holds only one record. The fields in the record are separated using delimiters such as tabs and commas. Sa model na to, bawat user ay may sariling database. Exclusive lang yung information and database sa owner ng file and hindi siya pwedeng ma-share sa iba. Kaya if ever na need ng other users yung ganong data, kakailanganin pa nilang mag-start ng bago para magkaroon ng ganong data. Usually, ginagamit yung flat file approach sa mga simple applications na konti lang yung mga data na kailangan. Next slide, please. Figure 9-1 illustrates the flat file model. In the figure, the file contents are represented conceptually with letters. Each letter could signify a single data attribute, a record, or an entire file. Kung mapapansin nyo rin, yung data element B ay present sa lahat ng users. Ang tawag doon ay data redundancy. Yun yung nagiging cause ng 3 types of data management problems. Next slide, please. Kung mapapansin niyo sa presentation, 4 siya and nakahiwala yung isa. Ito ay dahil yung tatlo, which is yung data storage, data updating, and yung currency of information ay yung main problems na directly related dun sa flat file approach. Kung yung nasa baba naman, which is yung task data dependency, ay problem din siya sa flat file database approach, pero hindi siya directly related to data redundancy. So now let's discuss them one by one. First is yung data storage. Some commonly used data may be duplicated dozens, hundreds, or even thousands of times, creating excessive storage costs. Gaya na nga lang nung dun sa data element B kanina, dun sa 9-1 na figure, since mauulit yung data, lalaki rin yung storage na kakailanganin para ma-store yung mga data na ganon. Next is data updating. Organizations have a great deal of data stored on master files and reference files that require periodic updating to reflect operational and economic changes. Halimbawa na lang nito ay yung pagpapalit ng pangalan ng isang customer. Dapat magre-reflect din yung change na yun dun sa master files. This piece of information may be important to several users, the user departments in the organization such as sales, billing, credit, customer service, sales promotions, and catalog sales. Since ang flat file nga ay nagme-maintain ng separate files, yung mga ganitong changes must be made separately for each user. And eventually, nag-a-add siya ng significant cost dun sa data management. Next is yung currency of information. This is the timeliness of information. In contrast to the problem of performing multiple updates ay yung problem of failing to update. the files of all users affected by a change of some information. Gaya na nga nung pag-change nung name ng customer. Like, what if hindi napalitan dun sa isang department? So, ang mangyayari dun, if update messages are not properly disseminated, then some users may not report the change and will perform their duties and make decisions based on the outdated data. Now, let's move on to task data dependency. The user's inability to obtain additional information as his or her needs change. It is the user's information set is constrained by the data that he or she possesses and controls. So para mas maintindihan natin yung task data dependency, tingnan natin ulit yung figure 9-1. Next slide please. Ayan. For example, need ni user 1 yung data L. Si data L present siya sa user 3. User 1's program would not have access to this data. Although yung data L ay nag-exist sa files ng other user, keep in mind that sa flat file approach, users do not interact as members of a user community. They act independently. As such, user 1 may be unaware of the presence of data L elsewhere in the organization. In this environment, it is difficult to establish a mechanism for the formal sharing of data. Dahil dito, kailangan ulit gawin si data L from scratch, which will take time, inhibit user 1's performance, add to data redundancy, and it could also drive data management costs even higher. Next slide, please. Now let's move on to database approach. Database approach, users can share information because they are all connected to a database that stores all the information. Pero hindi lahat pwedeng ma-access. Only the authorized user can access the data. And it also provides facilities for querying, data security, and integrity, and allows simultaneous access to data by a number of different users. Next slide, please. So, figure 9-2 shows the database concept. Makikita niyo naman sa figure na to yung obvious na difference niya from flat file. Sa database approach, yung pooling ng data sa common database ay nasa-share na sa lahat ng users. Ayan, user 1, user 2, user 3, nakikita na nila lahat ng database from A to M. To continue the presentation of database approach, may I call on Ms. Nicole Cantero. Thank you.
Thank you, Ms. Yell, for that concise introduction of flat file and database approach. Next slide, please. Now we'll look into some effective solutions to the problems that might develop when utilizing flat file system through the use of database approach. As mentioned earlier, flat file system struggles with data redundancy. With the help of database approach, each data is stored only once, thereby eliminating data redundancy and reducing storage costs. For example, instead of maintaining multiple copies of the same vendor details in different flat files, database approach normalizes the data by having a central vendors table that stores vendor details. We can use the vendor's ID as a foreign key in other relatable tables. This approach reduces redundancy and ensures that updates to vendor information are consistent throughout the system. Next, we have the single update. The single update problem refers to the challenge of updating a specific piece of data consistently across multiple instances of that data in a flat file system. This problem arises due to the data redundancy, where the same information might be duplicated across various files, making it difficult to ensure that the updates are applied uniformly. With database approach, it helped to reduce time and cost of keeping the database current. Next, we have the current values. The current values problem in a flat file system refers to the challenge of accurately maintaining and accessing the most current or up-to-date values of specific data across multiple files. This issue can arise due to the lack of a centralized mechanism for managing and updating data in real time. Using database approach, you can always access the most recent and accurate information without worrying about outdated values. Lastly, we have task data independence. The task data independence problem in a flat file system refers to the difficulty of performing different tasks or operations on the same data without directly affecting the structure of the data or other tasks. This problem arises because flat file systems lack the inherent flexibility and organization that databases provide. So with database approach, it ensures that different departments or tasks can work with the same data while maintaining data consistency, integrity, and security. The relational database structure and features enable efficient and effective data management across various use cases. Next slide, please. Next, we have controlling access to the database. This discusses how does database control who can access the information. The database approach places all the firm's information eggs in one basket. It is essential, therefore, to take very good care of the basket. The example in figure 9-2A has no provision for controlling access to the database. Assume data X is sensitive, confidential, or secret information that only user 3 is authorized to access. So how can the organization prevent others from gaining unauthorized access to it? Next slide, please. So to answer the question, the organization prevent others from gaining unauthorized access to specific information by using database management system. So what is a database management system? DBMS provide control access to the database. It is a special software system that is programmed to know which data elements each user is authorized to access. DBMS is like having a secure digital lock on your financial vault. It ensures that only authorized individuals within the accounting profession can enter and interact with your financial data. This controlled access helps protect sensitive financial information and maintains data integrity. An example would be, imagine your financial data as a valuable treasure stored in a digital vault. Just as you wouldn't want anyone to have the key, a controlled access DBMS ensures that only the right people with the right permissions can unlock and access your financial vault. Next slide, please. Lastly, on my report, we have three conceptual models of database approach. First, we have hierarchical model. The structure of the data is organized in a tree-like structure with parent-child relationships, which may not align well with the dynamic and interconnected nature of accounting data. Next, we have the network model. The structure of the network model is organized in a network-like structure with records connected through multiple parent-child relationships. The network model's ability to handle many-to-many relationships is more relevant to certain accounting scenarios. It can accommodate more intricate data connections commonly found in accounting, such as transactions involving multiple accounts and projects. Lastly, we have the relational model. The structure of the data in a relational model is organized into tables, consisting of rows and columns. It aligns well with accounting requirements for organized data storage and reporting. It allows accountants to define various tables for accounts, transactions, customers, vendors, and more, establishing clear relationships between them. To conclude, the choice of model depends on the nature of data relationships and the requirements of the application. While the hierarchical and network models have historical significance, the relational model has become the foundation for most modern database systems due to its flexibility, simplicity, and wide adoption. That's all for my part. For the next presenter, may I call on Ms. Giselle Paglinawan to discuss the elements of the database environment.
Thank you, Ms. Nicole. Again, a pleasant afternoon, ladies and gentlemen. I will be going to report the elements of the database environment. Next slide, please. So, figure 9-3 presents a breakdown of the database environment into four primary elements: the users, the DBMS or the database management system, the database administrator, and the physical database. In this section, we examine each of these elements.
Figure 9-3 shows how users access the database in two ways. First is via user application programs that systems professionals prepare. This is this program send data access requests, to the DBMS, which validates the request and retrieves the data for processing. The second method of data access is via direct. Sorry for the interruption. So the second method of database is via direct query, which requires no formal user programs. The query provides a friendly environment for integrating and retrieving data to produce ad hoc management reports. Next slide, please. Again, the four primary elements of database management are user, database management system, database administrator, and physical database. Next slide, please. The second element of database approach is the database management system. This provides a controlled environment to help or prevent user access to the database and to efficiently manage the data resource. It has four features. It includes program development, which is, let me read this for all of you. The database management contains application development software. Both programmers and end users may employ this feature to create applications to access the database. Next is the backup and recovery. In the event of a disaster, for example, this failure or malicious act that renders the database unusable, the database management can recover an earlier version that is known to be correct. And without the backup and recovery feature, the database would be vulnerable to total destruction. Next slide, please. Next is the database usage reporting. The database administrator uses this information to help in assigning user authorization and in maintaining the database. We discussed the role of the database administrator later in this section. And last is the database access. The most important feature of a database management is to allow authorized user access to the database. Next slide, please. There are three software models under database access. First is the data definition language or the DDL. This is used to define the physical database to the DBMS. It defines the database on three levels. It's called the internal view, the conceptual view or schema, and the user view or sub-schema. Next slide, please. So first is the interval view. This is the lowest level of representation, which is one step removed from the physical database. The internal view describes the structure of records, the linkage between them, and the physical arrangement, as well as the sequence of records in a file. The next, which is the conceptual view, which is the schema, this view allows users programs to call for data without knowing or needing to specify how the data are arranged or where the data resides in the physical database. And last is the user view. To the user view is the database. Unlike the internal and conceptual views, many distinct user views exist. Next slide, please. I will not read this part, but to illustrate the roles of the three views, this is the typical sequence of events that occurs in accessing data through a database management. The following description is hypothetical and certain technical details are omitted. Next slide, please. Next software model under DBA is data manipulation language. It's the proprietary programming language that a particular DBMS uses to retrieve, to process, and to store data. Next slide, please. Last is the query language. The structured query language known as SQL or simply SQL is essentially a language that communicates through databases. If you want to add or delete or edit information on a database, the easiest way to do is through SQL. Next slide, please. Going back to figure 9-3, the database administrator is responsible for managing the database resource. In large organizations, the database administrator function may consist of an entire department of technical personnel under the database administrator. The duties of the DBA fall into the following area, namely database planning, the design, database implementation, database operation and maintenance, and the change and growth. Next slide, please. Figure 9-6 shows some of the organizational interfaces of the database administrator. Of particular importance is the relationship among the DBA, the end users, and the systems professionals of the organization. Next slide, please. So the fourth element of the database approach as presented in figure 9-3 is the physical database. This is the lowest level of the database. The physical database consists of magnetic spots on magnetic disks. The other levels of the databases, for example, the user, the conceptual, and the interval view, are abstract representations of the physical level. At the physical level, the database is a collection of records and files. There is what we call index sequential file, and it facilitates both direct access to individual records and batch processing of the entire file. Multiple indexes can be used to create a cross-reference called an inverted list, which allows even more flexible access to data. An index sequential file is important because it contains a fast and efficient method for huge amount of data. In this method, files can be easily stored in cheaper storage mechanisms like magnetic tape, and it's simple in design. It requires not much effort to store data. So that's all. The next section examines the principles that underlie the relational model and the techniques for creating relational tables for index sequential files. You will also see how tables are linked to the other tables to permit complex data representation. Thank you.
Thank you. We will now discuss the relational database model. What is a relational database? Edgar Codd proposed the principles of the relational model in the late 1960s. A relational database is a collection of information that organizes data points with defined relationships for easy access. This stores data in tables that consist of rows and columns. In a relational database, each row in the table is a record with a unique ID called the key. The columns of the table hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish relationships among data points. Accordingly, a system is relational if it 1. Represents data in the form of two-dimensional tables such as the database table, and 2. Supports the relational algebra functions of restrict, project, and join. In the enterprise, relational databases are used to organize data and identify relationships between the key data points. They make it easy to sort and find information, which helps organizations make business decisions more efficiently and minimize costs. They work well with structured data. This figure shown is an example of a relational table. In the world of relational databases, there is a distinction in the terminology used by developers and that used by users of the database. A developer of a relational database refers to file as a relation, a record as tuple, and a field as an attribute. On the other hand, a user of relational database refers to a file as a table, record as row, and field as a column. File is a collection of data within the database. It is a fundamental concept of the relational database model where data is organized into tables. Each file may have a name associated with the type of data it holds, such as customers or orders. Record represents a specific data entry or instance of the expected entity. Field, this is the category in a table. Moving on to the relational database concepts. I've listed 7. We have number 1, entities. In the context of relational database, an entity is a distinct object, concept, or item about which the organization wants to store data. Entities can be physical, like products, customers, or employees, as well as abstract, like orders, transactions, or appointments. Entities serve as the building blocks for organizing and structuring data in database. Second, occurrences. An occurrence refers to an instant or record that corresponds to a specific entity. For example, if the entity is customer, each individual customer's data, such as name, address, etc., is an occurrence. The term occurrences emphasizes that the same type of entity can have multiple instances of or records in the database. Third, attributes. Attributes are the characteristics or properties that define an entity. For instance, if customer is an entity, its attributes might include name, address, phone number, and so on. Attributes hold the actual data that describes the characteristics of the entity's occurrences. Fourth, user views. A user view is the subset of data that a specific user or group of users is allowed to see or interact with. Views are customized representations of the data based on the needs and permissions of different users. They can involve specific tables, specific columns, and even predefined queries or calculations, offering a tailored perspective of the data to different users. Fifth, association between entities. In the data model, entities can have relationships with one another. The labeled line connecting two entities describes the nature of the association between them. This association is often expressed using a verb such as ships, requests, or receives. These relationships indicate how different entities are related or interact with each other within the database. Sixth, physical database tables. The physical implementation of a relational database involves translating the conceptual data model, which includes entities, attributes, and relationships, into actual database tables. Each entity in the model becomes a separate physical table in the database. For example, if you have an entity named employee, you'll create a physical table named employee to store the relevant data. Lastly, cardinality. Cardinality defines the degree of association between two entities in terms of how many occurrences in one entity can be associated with occurrences in another entity. It describes the number of instances or records in one table that can be linked to a single instance in a related table. For example, a one-to-many cardinality means that one occurrence in entity A can be associated with multiple occurrences in entity B, while a one-to-one cardinality means one occurrence in entity A is related to exactly one occurrence in entity B. In summary, these relational database concepts are foundational elements for understanding how data is structured, stored, and related within a relational database system. They provide the structure and framework for designing and managing databases that efficiently store and retrieve information. Now let's turn to anomalies. Anomalies are the problems that can occur in a poorly planned, unnormalized databases where all data is stored in one table. Specifically, anomalies include update, insertion, and deletion anomalies. Update anomaly. It results from data redundancy in a normalized table. Redundancy refers to the repetition of the same data in multiple places within a database. In an unnormalized table where data is not properly organized, the same value might be stored in multiple rows, leading to redundancy. Let's say you have an unnormalized table with customer information, including customers' names and their respective orders. If a customer changes their name, you would need to update all occurrences of their name in the table. If you miss one occurrence, inconsistencies arise where the customer's name is not the same across all their orders. Next is insertion anomaly. An insertion anomaly occurs when the structure of the database makes it difficult or impossible to add a required piece of data. Poorly designed and normalized databases may lack the necessary structure to accommodate new data without introducing errors or violating constraints. Third and last, the deletion anomaly. A deletion anomaly arises when deleting a record from a database unintentionally removes another required data. So, imagine you have an unnormalized table with orders and their associated products. If you delete an order that happens to be the only instance of a particular product, that product's information would also be lost. The deletion of one record leads to the unintended loss of other related data. Just like in the example, the deletion anomaly may go undetected, leaving the user unaware of the loss of important data unless it's too late. This can result in the unintentional loss of critical accounting records and the destruction of audit trails. Table design, therefore, is not just an operational efficiency issue. It carries internal control significance that accountants need to recognize. Let's move forward to data normalization. Data normalization is a process used in relational database designed to organize data and minimize anomalies. The goal of normalization is to structure data in a way that eliminates these anomalies and improves data integrity. The normalization process involves dividing tables into smaller related tables and establishing relationships between them. Before moving on to the different forms of data normalization, we need to first understand the concept of keys in SQL. SQL, or Structured Query Language, is a domain-specific language used for managing, querying, and manipulating relational databases. This serves as a powerful tool for interacting with relational databases, enabling users to manage data effectively, retrieve specific information, and perform various operations that contribute to the overall efficiency and functionality of database systems. Here are the most common type of keys. Number one, primary key. A primary key is a single column used to uniquely identify a table. Composite key, a set of columns used to uniquely identify the rows in a table. Foreign key, a key that references the primary key of another table. Going to data, let's go on to the data normalization forms. Data normalization forms, often referred to as normal forms, are a set of rules or guidelines in a relational database design that help organize data in a way that minimizes the redundancy and maintains data integrity. Data normalization can be divided into different types of normal forms. The most popular ones are 1NF, 2NF, 3NF, and BCNF. Let's go on to 1NF, or first normal form. This is the most basic form of data normalization, which ensures that there are no two same entries in a group. For a table to be in the first normal form, it should satisfy the following rules. Number one, each cell should contain a single value. And number two, each record should be unique. This form eliminates duplications within a single record. Number two, 2NF, or second normal form. To achieve 2NF, a table must first be in first normal form. Then it should eliminate partial dependencies, which occur when non-key attributes depend on only part of the primary key. This involves splitting the table into multiple tables to isolate related attributes. Number 3, 3NF or third number form, normal form. A table in 3NF must satisfy the conditions of 2NF and also eliminate transitive dependencies. Transitive dependencies occur when an attribute depends on another non-key attribute rather than directly on the primary key. Achieving 3NF requires further splitting tables to remove these dependencies. Last, BCNF or Boys and Cod normal form. BCNF is a stricter version of 3NF and is also known as 3.5NF. It ensures that every non-trivial functional dependency involves a superkey, which means that all attributes in the table contribute to the determination of other attributes. Achieving BCNF may require additional table splitting to remove any anomalies. So, for a table to be in BCNF, it should satisfy the following rules. Number 1, it should be in 3NF, and number 2, for each functional dependency, X and Y, X should be a superkey. Going down to my last two topics, linking normalized tables and degree of associations. So for linking normalized tables, when unnormalized tables are transformed into multiple normalized tables, typically in third normal form or higher, these tables need to be linked together to maintain the relationships between the data. This is done through the use of foreign keys. Foreign keys are columns in one table that reference the primary key of another table, establishing connections between related data and allowing for effective querying and reporting. Next, for the degree of associations, we have three. First, one-to-one association. In a one-to-one association, a relationship exists between two tables where each row in one table is related to at most one row in another table. One of the primary keys can be embedded as a foreign key in the related table, creating a direct link between the two tables. Second, one-to-many association. In a one-to-many association, a single row in a one table is related to multiple rows in another table. The primary key of the one side, which is the parent, is embedded as a foreign key in the many side, which is the child table. This establishes a connection from the child table back to the parent table. Last, many-to-many association. Many-to-many associations occur when multiple records in one table can be associated with multiple records in another table. To handle such associations, a linked table is introduced, which contains a combined key made up of the primary keys of both related tables. This linked table allows for efficient representation of these complex relationships. That ends my report. We will call on Mr. Talens to report the next topic.
Thank you, Ms. Camela, for the brief and concise discussion about the relational database model. Now let us talk about designing relational databases. So next slide, please. The focus will be on the following 6 phases of database design, which are collectively known as view modeling. The steps are: first one is identify entities. Second is construct a data model showing entity associations. Third one is add primary keys and attributes to the model. Fourth one is normalize the data model and add foreign keys. The fifth one is construct the physical database. And the last one is prepare the user views. Next slide, please. So entities are presented as nouns in a system description. A number of candidate entities can be identified in the previous description: purchasing agent, receiving clerk, in inventory, supplier, inventory status report, purchase order, and receiving report. Not all of these candidates are true entities that need to be modeled in the database. To pass as valid entities, two conditions need to be met. The first condition is an entity must consist of two or more occurrences. The second is an entity must contribute at least one attribute that is not provided through other entities. We need to test these conditions for each candidate to eliminate any false entities. View modeling begins by identifying the primary entities of the business function in question. To determine primary entities, select the objects that are important to your business. The end users of your application can be a good source to help you identify primary identities. They know what the entities are for their particular business because they physically handle them every day. So next slide, please. The next step in view modeling is to determine the associations between entities and document them with an ER diagram. Recall that associations represents business rules. Sometimes the rules are obvious and are the same for all organizations. Sometimes the association between entities is not apparent because different rules may apply in different organizations. To reiterate an important point made earlier, the organization's business rules directly impacts the structure of the database tables. If the database is to function properly, its designers need to understand the organization's business rules as well as the specific needs of individual users. The next step in view modeling is to determine the associations between entities and document within the ER diagram. If the database is to function properly, its designers need to understand the organization's business rules as well as the specific needs of individual users. So next slide, please. The next step is add primary keys and attributes to the model. The analyst should select a primary key that logically defines the 9 key attributes and uniquely identifies each occurrence in the entity. Add primary keys. The next step in the process is to assign primary keys to the entities in the model. The analyst should select a primary key that logically defines non-key attributes and uniquely identifies each occurrence in the entity. Sometimes, this can be accomplished using a simple sequential code such as invoice number, check number, or purchase order number. Sequential codes, however, are not always efficient or effective keys. Through careful design of block codes, group codes, alphabetical codes, and mnemonic codes, primary keys can also impart useful information about the nature of the entity. Add attributes. Every attribute in an entity should appear directly or indirectly, or a calculated value in one or more user views. Enti- entity attributes are therefore originally derived and modeled from user views. In other words, if stored data are not used in a document, report, or a calculation that is reported in some way, then it serves no purpose and should not be part of the database. So next slide, please. The next one is normalized data model keys. The normalization issues that need resolution are outlined in the following selection. The first one is repeating group data in purchase order. The attributes part number, description, order quantity, and unit cost are repeating group data. This means that when a particular purchase order contains more than one item, or most of the time, then multiple values will need to be captured for these attributes. To resolve this repeating group data will remove to a new PO item detail entity. The new entity was assigned a primary key that is a composite of part number or PO number. The second one is repeating group data in receiving report. The attributes part number, quantity received, and condition code are repeating groups in the receiving report entity and were removed to a new entity called rec report item detail. A composite key composed of part number and rec, rep number was assigned. The third and the last one is transitive de dependencies. The purchase order and receiving report entities contains attributes that are redundant with data in the inventory and supplier entities. The main purpose of this is to minimize the redundancy and any other anomalies. It divides larger tables to smaller ones and link them using relationships, normalizing at a low level such as 1NF or first normal form And 2NF or second normal form may cause anomalies, but anomalies will not exist when normalized at a third normal form. So next slide, please. So the next step is construct the physical database. Each record in the rec report item detailed table represents an individual item on the receiving report. The table has a combined key by comprising rep number and part number. This composite key is needed to uniquely identify the quantity received and condition attributes of each item detail record. The rep number portion of the key provides the link to the receiving report table that contains general data about the receiving event. The part number portion of the key is used to access the inventory table to facilitate updating the quantity of on-hand field from the quantity received field of the item detail record. The PO item detail table uses a composite primary key of PO number and part number to uniquely identify the order quantity attribute. The PO number component of the composite key provides a link to the purchase order table. The part number element of the key is a link to the inventory table where description and unit cost data reside. The next step is to create the physical tables and populate them with data. This is an involved step that must be carefully planned and executed and may take many months in a large installation. Programs will need to be written to transfer organization data currently stored in the flat files or legacy databases to the new relational databases. Data currently stored on proper documents need to be entered into the databases tables manually. Once this is done, the physical user views can be produced. Let us have our next reporter, Mr. George Paglinawan, for the continuation of the discussion about the designing relational databases. Thank you.
So thank you. Good day, everyone. I am George Paglinawan, and I will be presenting to you the last phase of designing relational database, which is prepare the user views. The normalized table should be rich enough to support the views of all users of the system being modeled. Meaning to say, we should make tables organized and complete enough for everyone using the system. For instance, take a look at this figure showing the normalized table. The passage provides an example of a user views, in this case, a purchase order or the PO entry screen for a purchasing clerk. The fields in the user views are cross-referenced via circled numbers to the attributes in the supporting tables. This view is constructed using attributes from multiple normalized tables. So what do you mean by cross-reference? It tells that the user view attributes are linked to their respective tables and fields using circled numbers or references. This allows users to see where the data in the view originates from and how it is related to the supporting tables. Next slide, please. Remember, these tables can also provide data for other things like reports and lists, such as a report about received items, a list of purchase requests, a report showing what is in the inventory, and a report about vendor purchases. In a database system, the query function let the designer easily create views gaya ng mga screens or reports using these tables. Like, yung mga designer, pwede siyang magsabi sa system kung anong table yung gagamitin, keys na i-connect, or kung aling details ang kukunin sa bawat table. In older systems, the designer uses specific instructions in the language called the SQL, or the structured query language. Newer systems make this process visual. The designer clicks on the tables and details. The system then creates the SQL commands and automatically to get the view. Next slide, please. So to simply put, this focuses on the idea that normalized tables are the foundation for creating user views in a relational database system. And newer technology allows for easier generations of these views without extensive SQL expertise. So this figure shows the normalized data model. It refers to a way of organizing data in a relational database to reduce redundancy and ensure data integrity. This model is designed to improve the efficiency and accuracy of data storage and retrieval. Normalization involves breaking down data into smaller, related tables and establishing relationship between them. The goal is to eliminate data duplication and anomalies that can arise when information is stored redundantly. So makikita natin dito, every table has relationship to each other. And lagi nating tatandaan na when preparing the user views, normalized tables should report all the required views of system users. And user views restrict users from having access to unauthorized data. Next slide, please. Now, let's discuss the global view integration. Para mas maintindihan natin to, imagine, nagtatayo tayo ng isang giant puzzle na gawa sa different pieces of information ng isang company. And each puzzle piece holds important details for different tasks like purchasing, selling stuff, and keeping track of what is in the stock. So first thing is that, ano yung magiging views nito sa different job? Think of a view like looking at specific pieces of a puzzle for a certain job, like buying things. You make many of these views for different jobs, and each showing only part of the puzzle. And these views help people in the company do their work better. Second, putting everything together. Now, picture a big picture that is made up of all these views, like a super puzzle that shows everything the companies needs to do. Making this big picture from all the little views is called view integration. It's like putting all the small puzzles together into one huge picture. Next is the modern company needs. In reality, companies have tons of different tasks, so they need many views and pieces of information. To make this big picture, you need a way to combine all these views into one organized set of information. The next is ERP system help. Special system called Enterprise Resource Planning or ERP system can help with this. They come with a basic set of puzzle pieces or what we call the core schema that is already organized and ready to use. These pieces includes common things like information about what the company sells, who buys from them, and who supplies them. Customizing for jobs. Instead of starting the puzzle from scratch, you can start with the core set of the ERP system. Then you can customize these pieces of fit exactly what each job needs. It's like having some of the puzzles done already and just adding the finishing touch. Adding new pieces. Sometimes the basic puzzle pieces might not cover everything the company needs. In that case, you can add new pieces to the puzzle to make sure everything is included. And lastly, the big goal. Whether you start from scratch or use an ERP system's core pieces, the goal is the same, which is to create a big, complete picture that everyone in the company can use. This big picture should have all informations needed for every job, and it should be easy to work with. So, global view integration means making a big, organized picture of information that includes all the different views needed for various jobs in the company. You can start with a basic set of puzzle pieces from an ERP system and then customize them to match the specific needs of each job. The result is a complete and well organized set of information that helps everyone in the company to do to do their work effectively. And that is all for my presentation. For the next topic, may we call on Miss Cheryl Roque to discuss. Thank you.
Thank you, Mr. Paglinawan, for that fruitful presentation. So, next slide, please. The majority of contemporary businesses employ distributed processing and networking to handle their transactions, with certain enterprises conducting all of their transactions through this method. A crucial aspect to contemplate when designing a distributive system is the placement of the organization's database. Good day everyone, I'm Cheryl, Roque, tasked to discuss the databases in a distributive environment. Next slide please. In addressing this matter, planners have two fundamental choices. They can centralize databases or distribute them. Additionally, distributive databases are classified into two types, partitioned and replicated databases. Next slide, please. So when we say centralized databases, it is the distant users utilize terminals to send data requests to the main hub. The central hub then handles these requests, processing the data before sending it back to the users. Aside from this, the main hub essentially functions as a file manager, catering to the data requirements of the remote users. Meanwhile, data currency is the firm's data files reflected accurately the effects of its transactions. Next slide, please. So the distributive databases. Distributive databases data processing, or the DPP, on the other hand, entails restructuring the IT role into compact information processing units, or the IPUs, that are allocated to end users and placed within their jurisdictions. These IPUs can be dispersed based on the business task, geographical regions, or a combination of both. Additionally, they are categorized as a partitioned or replicated databases. Next slide, please. So the data currency in a DPP environment. While processing data, the account balances go through a phase of transient imbalance, whether their values are inaccurately represented. This phenomenon takes place while any accounting transactions is being carried out. The rectifications of this disparity only takes place once the entire transaction is finalized. In a distributed data processing setup, these momentarily disparities have the potential to cause the lasting damage to the database. Next is the database lockout. Means to ensure up-to-date data. It's essential to avoid simultaneous access to specific data components by various locations. Hence, the resolution to this challenge involves implementing a database lockout, a software mechanism typically integrated into the database management systems, and this control prohibits concurrent access to the data. Next slide, please. So the partition databases. The strategy of a partition databases involves dividing the central databases into segments or partitions that are allocated to their respective primary users. This approach is most effective for organizations where the need for the data exchange among users at distant location is minimal. So the advantages are three, which are storing the data at local sites increase users' control. Second is permitting local access to the data and reducing the volume of the data that must be transmitted between sites improves transaction processing response time. And lastly is partition databases can reduce the potential for disasters. By having data located at several sites, the loss of a single site cannot terminate all data processing by the organizations. Next slide, please. So when we say deadlock phenomenon within a distributive setting, there's a potential scenario where multiple sites might mutually block one another, leading to the inability to process their respective transactions. Deadlocks arise due to the data being exclusively accessed, causing transactions to halt until locks are released. These situations can lead to incomplete transactions processing and eventually data corruption. Deadlocks are enduring issues that necessitate specialized software to examine each deadlock and identify the optimal resolution. For the deadlock resolution, addressing a deadlock typically requires making a decision to forgo one or more transactions. This step is necessary to enable the completion of the remaining transactions that are entangled in the deadlock. The transactions that are paused need to be restarted subsequently. When precluding transactions, the deadlock resolution software strives to minimize the overall expenses of resolving the deadlock. Next slide, please. So these are the different factors to consider deadlock resolution. First is the resources currently invested in the transactions. It refers to the various assets, efforts, and elements that are currently committed or allocated to a specific transaction. These resources can encompass a range of factors such as time, money, manpower, computational power, data access, and any other necessary components that contribute to the execution and completion of the transaction. Second is the transaction stage of completion. It refers to the point at which a specific transaction currently stands in terms of its progress towards being finalized. Transactions can be thought of a series of steps or activities that collectively lead to a desired outcome. Each step contributes to moving the transactions from its initial state to a state of completion. Third one is the number of deadlocks associated with the transaction. It refers to the account of instances in which the transactions becomes entangled in a deadlock situation. Deadlocks occurs in systems with multiple processes or entities when each entity holds a resource that another entity needs, causing them to be mutually blocked and unable to proceed. Next slide, please. So the replicated databases. In a certain establishment, the complete database is duplicated at every location. Replicated databases are useful for businesses where substantial data exchange is prevalent, but no single user has a central role. Since shared data is duplicated across all sites, the volume of data transferred between locations is significantly minimized. Also, given that each site handles its transactions locally, various transactions will modify shared attributes that are replicated at each site. Consequently, each site will possess distinct values after these updates. Next slide, please. So for the concurrency control, databases concurrency involves maintaining precise and comprehensive data across all distance locations. Designers of systems must utilize strategies to guarantee that transactions conducted at its sites are faithfully mirrored in databases at every site. One widely employed approach for managing concurrency is to serialize transactions. In the serializing transactions, first, a special software groups transactions into classes to identify potential conflicts. And the second one is to timestamp each transaction. Assign a timestamp to each transaction. A universal clock synchronized across all sites, even those across the various time zones, is employed to maintain uniform logical time. An algorithm is utilized to arrange databases updates according to the transaction's timestamp and category. Next slide, please. So for the last topic under this chapter 9 is the distributive databases and the accountant. The choice to distribute databases requires careful considerations. Various constraints and compromises need to be taken into an account. Among the fundamental queries to be tackled are: first, should the organization's data be centralized or distributed? This sentence is asking whether the organization's data should be stored and managed into a central location or if should be spread out and managed across multiple locations. It's a question about how the data infrastructure should be designed and whether the data should be centralized in one place or dispersed to different areas. Next question is, if data distribution is desirable, should the databases be replicated or partitioned? This sentence is inquiring about how the data should be distributed if that approach is considered beneficial. Specifically, it's asking whether the databases should be replicated or partitioned. In here, we see that Replicated databases is a replication involves creating identical copies of the entire database at different locations. This ensures that each site has a complete set of data. And on the other hand, partition databases involves dividing the databases into segments or partitions, with each segment assigned to a specific location or user group. Third question is, if replicated, should the databases be totally replicated or partially replicated? This sentence is discussing the approach to take if replication of databases is chosen. Specifically, it's asking whether the replicated databases should be fully replicated or partially replicated. First, the fully replicated databases would mean that every piece of data, every record, and every update is duplicated across all locations. Each site has a complete copy of the entire database. Meanwhile, partially replicated databases within a partial replication, only a subset of the data is replicated to each location. Different sites must have different portions of the database replicated based on their specific needs. And last questions, if the database is to be partitioned, how should the data segments be allocated among the sites? This sentence is discussing the decision-making process for allocating data segments among different sites when the approach of partitioning the database is chosen. Moreover, it is essentially highlighting the need for careful planning and decision-making regarding the distribution of data segments when employing a partitioning approach for the database. And next slide, please. So this concludes our report. I hope you learned in our group's presentation. Thank you and have a nice day ahead.